All right guys, I'm doing a 360 tour of the house, and really quickly how the 360 works. If you are on your phone, you can just turn around. If you're looking at it on your phone, it moves along with you. If you're watching this on your desktop, I don't know if you can do this on your TV, but I know on your desktop what you can do is just click on the video, kind of scroll around so you can see all the way around. So that's really quickly how the 360 video works. It's a little bit different than the normal videos, but it is interactive. You can look up, you can look down, you can look all the way around. So I just want to give you a quick update on our Hobbit House, also known as Toitu, and also earthen structure. We've got most of the framing in place. We're doing a little bit of cleanup right now, and we're getting ready for waterproofing. So next week we're going to be working with Polyguard and also our waterproofing contractor to show properly how do you get all the control layers on the outside of the house so we don't have to worry about water coming in. So we do have water coming in, and I'll show you inside the house real quick that even though you do have concrete, it does not mean that water is not going to get in. So this is porous. Water can find its way through the cracks, and that's why you always do waterproofing on concrete and have that vapor barrier. Now, earlier I did a video on what we have to do for the zip system. Concrete also is porous as far as air. There's an air rating for that. So I learned this when I was doing passive house. Actually, if you have a concrete wall, air can go through that. And I think on a few blower door tests, that was some of the failures in our projects, was where I had a concrete. I assumed that air wasn't going through, and it was. So in this house, we're going to seal from the outside and also the inside for the air. So this is our primary barrier for air and vapor, is the zip system, and we're going to put mineral wool on top of that. So between that and the windows, this is where the opening is and where most of the air would come through on a traditional building, but in this case we're not going to have that issue because we know that the zip tape, liquid flash, and this is our WRB, this is essentially airtight. And once you put the tape on and you also have the liquid flash, you're in great shape. The air back to this room, and let me go upstairs really quickly to show you how this is going to get filtered. So a couple bedrooms over there, we can do that later on the tour, but I mostly want to tell you how these mechanicals are going to work. So these stairs, we're putting, I believe, oak hardwood down. We're going to site finish, so the whole upstairs is going to be site finished oak. It's going to look really nice. But right here where I'm standing in this area, this is where the air is going to come up. It's going to come from the downstairs, come into the attic, and basically we're going to drop back down into the mixing room over there. In the middle right here, we've got two fans that are two filters are going to go in place, where the total surface area of that, or the open area, is 12 square feet. So lots of good airflow on that, and they're going to be either 4 or 6 inches deep, which means that lots of air can go through there without much static pressure loss. Here's our radon vent, and very big. We're looking for a passive system. We will do some testing to see how that works. If we need to, we can add a fan to the roof or add a fan in here. We're basically drawing the air from the slab. We did a video, or we're going to do a video on how we put the radon system underneath the slab. But essentially you just want to create a good air barrier underneath the slab, have pipes where you can get all those gases out. Electrical's coming in down here. You can see we've also got something for low voltage wires. You want to keep your low voltage away from your high voltage because the electromagnetism from the high voltage affects that. So those have to be different openings. And where it gets really interesting is where we have the pipes going through the roof. Each of those has to be waterproofed. We designed this so we have as few penetrations as possible, especially penetrations through this shell, because there has to be extensive waterproofing on this. We don't mind having penetrations in the wood, mostly because that's already covered, and we've got lots of good sealing details for that, and it's not going to be buried in the dirt. Little common area over here, and this is one of the bedrooms. So we've got a closet system going to be built into either side, a desk in the middle, but this is going to go out to a Juliet balcony all the way across. And instead of windows, you've got doors, so that's your egress. So on this side of the house, you have 4 doors instead of windows, but we've got lots of glass in there. So all the natural daylight that you see right now is going to come into the house. And you can see this is one of the areas right here. We're going to need to seal from the outside. We're going to use the Zip liquid flash on that, just to make sure all of our penetrations are sealed up. So great view. And once we get the berm, the plastic taken away, some more landscaping, and all this flattened out, this is gonna be, you know, something fun to wake up to every morning. Same thing on the other side, kind of mirrors this same plan. It's basically just flipped 180 degrees. So that's kind of what we're doing here. Some of the fun things that we've tried out on this house, we are mostly doing 2x6 framing because we do have a lot of mechanicals in the wall, and we didn't want to compromise the framing by drilling so much. But in these outside walls, to get more insulation, when I say insulation that's in the walls, because we are doing outsulation to prevent some more thermal bridging. But look at this, my hand's going all the way through right here. So by having these staggered studs, this allows for more continuous insulation without any thermal breaks. And why that's important is the insulation is approximately R4 per inch, where this piece of wood is R1 per inch. So if we have 2 inches back over here, we have R8, which that 2 inches right there is over twice as much R value as this 4 inches right here. So it's very important to have continuous insulation. If you can, my friend Steven Saunders Myers does this on all of his houses that they do a spec, and essentially most of those are net zero energy. So it's an amazing way of building. So a couple other things over here. This whole area, you see this little catwalk. This is mostly for the mechanicals. We're gonna have lots of ducts running through here. And the space behind the closet, again, this is not going to be used as storage. This is gonna be our makeup air system from Fantech. We're going to install this here. That's going to bring the makeup air into the kitchen. And the reason we need that, this house is so tight. When we were sucking and depressurizing the house by exhausting all the pollutants out from the kitchen, the air has to come in from somewhere. And we're gonna have a mechanical fan-based system where it's pushing that air into the house at the same rate as the air is being exhausted out towards the other side of the house. And one thing that most people don't consider, when you've got a garage like this, you notice this garage wall, it's not wide open. We put the sheathing on it. And the reason is we're going to use that zip system as that air barrier. So it's adding a lot of rigidity to this wall, but all these walls are here. None of these are structural. The outside of the dome itself is the complete structure. We don't need any of the wood framing in here to help support that. So these walls are designed to basically hold themselves up. We use that same pattern over here where you've got these staggered studs where they're 24 on center, which means that you've got one of these every 12 inches, but this is a 12 inch to the outside, 12 inch to the inside. So the difference between this one and this one right here, where there's no space in between, is 24 inches. You could just fit more insulation in there. Something else we did, and we'll have to pull off this board right here because like you can't see it now, but we actually did leave a gap, or maybe they filled, actually I think they filled that in before they covered this up. But we designed this header where we can actually receive 2 inches of insulation. So this is an R8 header. So they put the Rockwell insulation, I know they did because we have all the insulation right here, in that wall before they covered up with the zip system. So that's already an insulated header. But this wall right here, we're using the zip tape, and I can see that they rolled it out properly because I can see the little Z's in there from them rolling it out. But this zip tape, we're gonna use liquid flash on the bottom, liquid flash on the sides. That whole system is what is gonna be our air barrier, because there's gonna be cars in here, and even though they're using electric cars, say if somebody in the future wants to use a gasoline powered car, or if you're storing chemicals out here, we don't want those chemicals getting into the house. And a system like this is going to allow us to create that air barrier, except for areas like this. You can see this gap around this. So we're gonna have to use a mud cup on the inside, completely seal that off, all those wires, to make sure air isn't getting through that box into that wall, which could potentially get inside the breathing space of that house, or that part of the house. One of the things I really like about this, check out this wide garage. So This insulation obviously is gonna be gone. This is gonna be the driveway. You see the dirt mound up there, all that's gonna come down to this level. So this is gonna be a parking pad, or really the pad where you're coming in. You could park there, but then the driveway is gonna go up from there. So all this is about 10 feet too high in that space. That's gonna come down, and we're going to basically ease into this pad so they can turn and pull into the driveway. What's really cool is, like, I'm looking at the street. You can kind of see part of the house from the street, but for the most part, the front of the house is towards the back of the lot. So there's not gonna be a lot of people looking at this. They're gonna see a little opening here, not really know what it is. And you're probably gonna miss it, because by the time we finish doing all the cutting in, take out our access driveway, all those plants are going to grow up again. And all you're gonna see in the driveway is actually on the opposite side of the lot. And from the driveway where that opening is, you can't see this opening right here. So it's gonna be a very, very private lot. So on the inside, this is not getting waterproof on this side, because even though this is being buried, we're waterproofing on the outside. This is going to get a finish on it. And to be determined, we're still experimenting with some different options. But where all the waterproofing is gonna happen is on the outside of the house. And you can see that we've got a little bit of demucking to do. So this is going to get, we've got the mini excavator coming in next week. We're gonna clear all this out. All this is gonna get ground down. This is going to be made smooth from the shotcrete all the way down to the footing. That way at the end of the next week, we can waterproof all this, keep the water out of the house, and all that water that you saw inside the house today will not be there in a couple weeks, mostly because we're gonna have a nice complete covering on this by Polyguard.